This morning's panel, as you know, is on reclaiming former industrial sites, and this ties really well into tomorrow's program, which I hope you'll also join us for. We're organizing the first ever public tour of Chevy-in-the-Hole since that site was closed. And we'll be doing 2 workshops to look at what are some of the important conditions on the site that everyone needs to know about in order to make informed decisions, and how can we activate that site in the short term. And I'm betting that these guys who are speaking this morning will have some ideas for us.
My name is Steve Montle, and I work for the Center for Community Progress here in Flint. The center is a national nonprofit that focuses a lot of time and energy and effort on vacant spaces, but it tends to be pretty neighborhood-based, and I'm not the only one in our organization that works on the brownfield side of things. So my focus is the Chevy-in-the-Hole project. I get up every morning and try to figure out ways to move what is a pretty complicated project forward. So I as well am pretty passionate about this project, and we're pretty excited about moving this thing forward. So
and just to give you guys a little perspective, when Steve and I kind of got involved in this, and this project brought us together, 3-4 years ago. A lot of the stakeholders that are now very positively involved in supporting Chevy-in-the-Hole were really initially kind of resistant, and for a lot of the reasons that a lot of themes that we'll touch on throughout this next couple days. So anyway, how do I?
Oh, it's the left button, or you can scroll down.
Okay, so you want to go ahead?
Yeah, I'll go ahead and start. So, on this whole concept of reclaiming vacant spaces or vacant auto brownfields in this case specifically, you've got all these puzzle pieces, and this is not really rocket science how to put these things together, right? They've been reclaiming vacant brownfields for a long time. So the idea here is you've got your puzzle pieces. We pretty much know the science behind it. We know the technology behind it. The layers get pretty complicated at times, and it's basically a sorting process, and then ultimately this idea of putting the pieces together, which you saw on that last slide here. But this is, let's just start here. So we've got,
hold on, Steve.
You're all over the place.
I just want to get this thing to play. No?
Yeah,
Forget it.
Forget it. But this is your typical, sort of upside development brownfield reclaiming scheme that we have here, right? So you start with impaired property. You have it's developer driven. 1 to 3 years, and basically you go in, you do a little community outreach. How does the community see this property, being used or being utilized in the future? You deal with some environmental issues on the site. You deal with the infrastructure issues on the site. You have a redeveloped project, and you're about 1 to 3 years in the timeline.
Yeah. This is a typical kind of brownfield master plan for brownfield redevelopment projects that we did a lot in Michigan from mid-90s to around 2008, 2009. Especially in communities like Traverse City, Ann Arbor. Communities that had waterfront, but that had maybe not so much economic impact from a big pullout of industrial jobs. Okay, so what I want to say is that was easy. Those were really easy. They were pretty fun, but they were easy, and they were developer driven, right? And that was the main impetus, is that you had somebody with a bunch of money who was willing to kind of drive this thing.
And another point to realize is on these developer driven deals, one of the reasons they're so easy is it's easy to fund them. You can put some kind of tax increment financing together. You can get, a lot of times you get public funding for these things. If it's a big project and it's going to be a big tax generator, you can publicly fund the infrastructure on these things. So, those elements make it pretty easy.
Yes.
Go ahead.
Well, and so this is what we kind of conceptualized as the new generation of brownfields. And when I say that this title, we've given this talk a lot of different places, and it's called Brownfields Next Generation. But what's left are the hard brownfields, the complex ones. That's what's left. The easy stuff is all done. The corner Walgreens, those are done. The riverfront developments in these really desirable communities, those are done. Okay, but what's left is the hard stuff. The Chevy-in-the-Holes, the places that are on waterfront in these old Rust Belt communities where, really there isn't a lot from an economic standpoint. So if we were going to wait for Chevy-in-the-Hole, for example, to be developer driven, that means we just put a fence up, some signs, keep out, and we wait until the economy turned around and a developer walked in here and wanted to build something there. Okay,
But in this site in particular, we're talking multi-generation,
Yeah.
right? This thing's going to sit for 10, 20, 30, 40 years before we see anything that even approaches that traditional developer-driven approach. So obviously, a different approach has to be taken on stuff like this.
So the approach we decided to take, going back about 3-4 years ago, was, well, we knew we had the impaired property, and we knew that the developer was really a long way away, okay? And we knew we had a bunch of issues, okay? We knew we had environmental issues, water quality, all these different aspects, recreation issues. And what we decided to do is to start letting some of these issues be the driver, be the catalyst to get some, to jumpstart some activity, okay? And I think these next few slides are gonna kind of set that stage. Now let's just jump in and start talking about Chevy-in-the-Hole.
Yeah, so Chevy-in-the-Hole is one of Flint's brownfields. Flint has approximately 1,000 acres of vacant industrial brownfield within the city, and these are big sites, okay? So from our 400+ acre Buick City property in the north end of Flint to the couple 100-acre Delphi east site that's over on the east side of Flint. So keep in mind, Flint had large factory sites north, south, east, and west, right? We only have one of those sites is still active, and that's the south site. So we have 3 of the 4 major manufacturing centers are now vacant. Chevy-in-the-Hole is an interesting case because as we look at how to revitalize these open spaces, some are easier than others, right? These are all sort of tough cases to crack, but some are real tough to crack. And so Chevy-in-the-Hole is probably the toughest of those, and we'll sort of go through all the issues that we have on redevelopment of Chevy-in-the-Hole. But when we talk about this idea, it's really about recycling our city. Okay, it's about coming in and finding these vacant spaces and finding some value in that space. And Chevy-in-the-Hole is a good example of this. It's our oldest brownfield that we have in the city of Flint. It's probably the oldest auto brownfield anywhere in the country. It was actually industrialized pre-auto industry when it was lumber and carriages were made down there. And so this is a site that's been back in the 1850s. It was developed industrial, and the driver on this site for us is that it sits directly in the core of our city. Okay, it's almost the exact geographic center of the city of Flint. And now let's see if we can. And this is how it looks today here.
Yeah, I mean, just to give you some setting, this is what it looked when it was viable. From the sky, buildings covered this approximately 130-acre site. This is what it looks like today.
Yeah, that's what it looks like. So the driver here is this thing sits right at the core of our community, and it continues to be this sort of reminder of Flint's past. Has very low development potential. It sits partially in a floodplain. All of the building foundations still exist there. It's has a channelized river that runs through the middle of it, and then it has the industrial contamination issues that we would associate typically with an old industrial brownfield like this. But where it sits is actually between all of our major institutions that we have in our downtown area. So our hospitals, our universities, the downtown itself, key neighborhoods, all physically actually look into this site. So if you're sort of on the 5th floor of a building downtown, you look down into Chevy-in-the-Hole. If you're on the 5th or 6th floor of either the hospitals, you look into Chevy-in-the-Hole. So it's truly sort of central to the community. And the redevelopment of this site, I truly believe, it serves 2 real functions. One is to actually physically remove the blight that we have at this site. It's a major scar in our community. It's a major impediment to near development to the site. But there's also a psychological piece to this, okay? And the psychological piece on Chevy-in-the-Hole is that it is probably our toughest site to redevelop. It's not our biggest, but it's our toughest to redevelop. And it's right in the middle of our community, and everybody looks down into it on a daily basis. You drive by this thing. And so the real driver here is that if we can fix Chevy-in-the-Hole, it sort of gives hope for fixing the other pieces, right? But on the other side, if we can't figure this out, it's pretty tough to imagine figuring out the greater how do you fix Flint issue, right? So it's symbolic, you know, it sits at the physical center, it has a psychological element to it, and I think it's got a momentum piece to it as well. So that's why we spend so much time on Chevy-in-the-Hole. And one thing to keep in mind is, you know, Joel's a scientist, I'm not, but the idea here is that this is not a science project. This is much more a social experiment. The science is pretty easy behind this,
Well,
right?
the science is easy, the science is fun, and originally that's what drew me to this project was the science aspect of it. I was a very technical person. I have 20 plus years studying ways to use bacteria to degrade complex contaminants, and that's what originally drew me to this project. 4 or 5 years ago was, hey, I want a place where we can do this, because I'm doing it all over the state of Michigan, and I wanted another site, and this one fit. And that's originally what turned me on, but then as I got involved in the project, to be honest with you, I realized that those aspects were going to sit in the background, and that the social aspects of this project were much more, one, they were things that we needed to conquer early to gain momentum, and they were more exciting, both personally and professionally. So, yeah, let's go, I want to go back just a little bit too, just to give you guys some perspective again. The site, and you're going to, of course, see it a lot here these next couple days. The site is bisected by a channelized Flint River. Here's the Swartz Creek. And actually the river flows to the west and then turns north to the Saginaw Bay. Okay. The channelized portion of the river was actually constructed in the 60s by the Army Corps of Engineers, and that was to accommodate Chevy-in-the-Hole, General Motors. Anecdotally, the stories are that there were 8-9 feet of flooding in the plants down here near the river, and it's called Chevy-in-the-Hole because it sits in this topographic depression. And anecdotally, some of the stuff I read was that GM was so heavily industrializing and manufacturing in this space that the flood line, even after the flood control project, the flood marks on the walls remained for the life of the factories, because they just never took the time to clean them off the walls, and you know, so it just gives you a feel. And really, I have some of these photos to kind of just give you a feel of how intensely manufactured this site was, to the gills, right? I mean, this was 8,000 people coming to this spot, manufacturing. This was the site of the sit-down strikes in the mid to late 30s, so you know, ostensibly the birthplace of the UAW, and so we went from that. You know, it's a microcosm of even what bigger things happen here in Flint, but to vacancy, to this stark wasteland. Okay, and again, as Steve mentioned, it sits at the center. It creates this huge discontinuity in the green space along the river corridor.
When you stand in the middle of Chevy-in-the-Hole, this is a good, you know, all of these institutions that you see, for the most part, when you're standing in the middle of what we call Parcel B, which is the big parcel on Chevy-in-the-Hole, and you look out and you see all these buildings, I mean, you got to think, those people can see in, right? And all of these institutions surround this. So you've got somewhere in the neighborhood of $400 million of investment within sightline, basically, of Chevy-in-the-Hole.
Yeah.
And so, you know, when we talk about Chevy-in-the-Hole, you know, this isn't a particularly expensive project, right? It's like south of $10 million to, we say, finish this thing completely. And that's dealing with contamination, capping the site where it's necessary, you know, adding the amenities. But then you think, like, what that adds to the greater projects that are within sight of it. That's sort of the real driver for funding this thing.
Yeah,
really.
yeah, and actually, and as some of you may know, and you'll find out as we go through this talk, we did a round of phytoremediation tree planting at the site this past year, and as I worked at the site more and more, especially in leaf-off conditions, this figure kind of hit me like, you know, wow, you can see all these places. When you stand down in Chevy-in-the-Hole, you see all this infrastructure and investment in institutions, and it really becomes apparent to you how this is a centroid of the city and vital to the rebirth of the city.
Part of the reason for that, too, is Flint's downtown developed differently than most downtowns in the Midwest, at least. So Flint in the 1920s was a small town, and the downtown in Flint is really a downtown that you'd see in a city of about 20 or 30,000 people. which is what Flint was in the 1920s, 1930s. It very quickly gained population. So we had a population doubling about every 10 years in the 1930s, the 1940s, the 1950s, into the 1960s. So we went from, in the 30s, a small town of, I don't know, 20 or 30,000 people, to 200,000 people in the 1960s. And the downtown never really developed at that scale, right? Flint is really, the city of Flint is really, if you look at it, more of a urban suburb, right? So as people moved in, neighborhoods were built out. The downtown wasn't necessarily built out, but these neighborhoods and institutions were built around our auto manufacturing, okay? So it's sort of like a small town, not a lot going on, autos take off, right, and start just ramping up. And then very quickly we had neighborhoods spring up around these auto sites. You know, our hospitals, instead of being concentrated in downtown, are kind of spread out across the, sort of west part of the city. So if you think of our assets, it's a little tougher than, a lot of cities' downtown redevelopment is fairly simple. You could sort of go block by block and, you revitalize the downtown. So then you've got this core of, 5 blocks wide, 10 blocks long, revitalized area. Where in Flint, we've done a great job with the downtown and revitalization, but it's a fairly small area, right? You've got to reach out much more broadly in Flint to be able to achieve revitalization than just be able to say, okay, 5 by 10 blocks, we're really going to concentrate on this area. You've got neighborhoods intermingled in here. You've got former auto manufacturing sites intermingled. You've got hospitals and universities that are kind of scattered around. And so what we're calling this is an institutional corridor. It's much, much bigger than what you would consider traditional downtown redevelopment. And as such, you've got to treat these auto sites like you would a vacant building on a corner during your downtown redevelopment, right? It's sort of like the broken windows theory of, you've got to fix that one piece on the corner and then you fix the next one down the line. Where in a lot of cities, these brownfields are sort of off to the corner of a city somewhere, or they're not central to like the redevelopment. Where in Flint, you've really got them central to the redevelopment because we built our city around, it's particularly this particular auto site. So.
All right, well, let's jump into the little more details about Chevy-in-the-Hole. As I said, it's roughly about 130 acres bisected by the channelized river. Presents this discontinuity in the riparian setting. And of course, as Steve mentioned, a litany of subsurface contamination that you would associate with this type of heavy manufacturing. Oils, solvents, petroleum, hydrocarbons, metals, all these things, some of them I would refer to as ubiquitous across the site. And they're in the media, they're in the environment, in the soils, and the groundwater. Okay.
And from a cleanup perspective, these are, for the most part, at fairly low levels. Okay, so I've been trying to figure out a way to communicate, when you say we've got a contaminated site and we want to reuse it, trying to really convey what that means and how reuse is. So think of it as these were sort of hazardous materials that are in low levels. These aren't sort of like toxic materials, right? So hazardous materials at low levels, so we're talking a lot of oil-based stuff, all the stuff you would associate with auto manufacturing is on the site at fairly low levels, and a lot of it's even below what we call this direct contact criteria, okay? So it's present, you can detect it, but it falls below the level that would be, you and I can walk around the site right now, okay? It's that low.
Yeah, so this is just a map of these 5 parcels are in control of the city. And for the purposes of this weekend, we're really going to focus on these 4 parcels, parcels B, C, D, and E. Parcel A, west of Chevrolet Avenue, represents, it's colored red here because it represents somewhat more of an urgent situation from the contamination standpoint. This is a parcel that we're going to stop and kind of let the EPA address this parcel over the next probably 5 to 10 years. This is not a parcel that we're going to go mucking around too much in the near term, okay? The rest of these parcels are what's in play south of the river. Kettering owns the bulk of Chevy-in-the-Hole to the north of the river, and they're definitely a big stakeholder in this process and very integrated into our project to the point where we're out actually collaborating together on some things. I'm not going to talk a lot about these red dots. I'm going to talk a little bit more about the environmental condition of the site here.
So think of this as sort of red is stop, yellow is proceed with caution, and green is sort of like you're pretty good to do redevelopment.
Yeah, it's very intuitive use of color. Yeah, the green is kind of like carte blanche, have at it. Okay, yellow is, let's be a little cautious, but there's definitely things we can do. Red is like, hey, stay away from that. Again, at the risk of being redundant, what are we left with here? We've got no development interest in the property, multiple contaminants, very complex urban hydrogeologic setting. Not to get too sciencey on you guys, but so it paints a pretty dire picture. You know, what do we have really going for us? And the tendency 4 or 5 years ago was to maybe just throw our arms up in the air and say, this is too hard. Screw it. We'll wait for somebody to come in with a bunch of money,
Right.
which would be, you know, not in our personal horizon, probably.
Right.
And so, you know, about 3 or 4 years ago, we started to change our thinking about this. You know, first of all, I'm not trying to take all the credit, but I came into it initially very geeked up about the science, technology aspects of the cleanup. And I thought to myself, well, we have a lot of space and we have no development pressure, so we have lots of time. So the techniques and strategies we use to improve the environmental quality of the site can take advantage of time and space. And technologies that take advantage of time and space can often be green technologies that are low impact, low energy, that are desirable from a regulatory standpoint and from a social standpoint, and also very fundable. So those are attractive technologies to maybe gain funding, seed funding, and maybe get some things off the ground on the project, on the property. Okay? Next slide. But beyond that, initially we started to alter our thinking from a science perspective. Then quickly thereafter, you know, Steve, myself, really this was kind of a mentality that just kind of spread throughout the group of stakeholders. We really began to alter our thinking about this property and project. And that is that our conventional thinking would be that we have all these issues, all these negatives. We need a bunch of money thrown at those to fix those. Okay? You know, the city doesn't, you know, city was broke, city was maybe on the verge of having an emergency manager. They don't have any money to throw at it, and the community doesn't really either. Our thinking was, okay, how can we leverage anything and everything on the property into an asset or resource that would help us kind of drive the reuse of this space? And maybe feature that in the reuse of the space, at least in the near term. And when I say near term, I'm talking kind of like the next few decades, until we can better the, you know, eventually maybe things will turn around and somebody will swoop in, Donald Trump will swoop in here and want to build something.
Build a tower.
Build a tower.
Seems to want to do that.
Build a hair club for men or something. So I added this picture here, and I actually added the slide to the talk just recently, because really, not to sound cliche, but what all we see, we kind of always see are frontiers here, you know. And the mentality that I was been kind of thinking about lately is that part of our mentality is, imagine if someone just plunked us down in that space and said, you know, you are going to exist in this space for the next 20 years. You know, like we're pioneers on the Wild West, plunk us down in Chevy-in-the-Hole. You got to exist here. So immediately our mentality would shift from, you know, we've got all these problems and we need all this money to fix them. No, it's going to be, our mentality is going to be, oh wow, how can we leverage everything here into a resource and an asset, including, you know, contamination and some other examples we're going to give. So an example I want to give of this that is happening now at the site, and you're going to see tomorrow, is thanks to Steve's idea, we started composting yard waste at the site. And this represented a big savings to the city to begin with, because they were spending a lot of money dealing with yard waste. But it also, on one hand, it presented another asset to us. And what we did is kind of fortuitously, this yard waste generates a lot of really high nutrient runoff, stormwater runoff. So when rain falls on these piles of yard waste, you get this basically liquid fertilizer. And then what did we do this past year? We planted trees for phytoremediation, and we, in some cases, planted them very close to these compost piles, and they basically received a bunch of liquid fertilizer running off the piles, and they grew from this tall in April to 13 feet tall right now. Okay, and so I think you'll see that tomorrow when you walk the site. You're going to be like, wow, yeah. There's the trees that kind of grew normal, like 4 to 7 feet across the site, and then there's the trees that grew to 13 feet tall. And this was a concept we've been wanting to test, and you know, like kind of serendipitously, we tested it, and it works. And so we're going to take advantage of that. That's an example of leveraging something negative. The DEQ would tell us we got to deal, if we're going to do biomass or yard waste, composting, you got to deal with this crap that runs off it. And we're saying, okay, this is how we're going to deal with it. We're going to grow trees with it.
We just literally 2 weeks ago, the city of Flint had a big meeting with the DEQ, and the DEQ came out and said, all right, you're doing all this composting, how do you want to deal with this water? And I'm saying, well, we're going to put it in the ground. And it completely freaks them out. They have no idea how to deal with that, right? Because everyone's always saying, well, we're going to put up these institutional barricades and we're going to try to filter this stuff out. And we're saying, no, we want this stuff on our site. We want this stuff going into the ground at our site so we can grow bigger trees faster, ramp up our remediation efforts. So what in normal cases is a problem product, which is this leachate or heavily nutrient-rich water, we're treating it, again, as an asset on the site.
So just a big altered shift in thinking. And we think that way about something really kind of cool and sexy like this. Another example, and this one hits a lot closer to my home, and this is what initially drew me to the site, is we have contamination. We have TCE, which is a known carcinogen at the site, was used for metalworking. We also know we have bacteria. These are actually bacteria that breathe TCE in the environment, and they're indigenous to the site. So we know when we have these two things that we can do some green technology incubation, and it can lead us to some grant money and some seed funding. Okay, and one of the concepts for the site is to take a portion of the site and do some green technology incubation, perhaps some job training. Okay, we're getting close, I know, guys, so bear with me. This is just another example of that technology. We're going to skip through it. But one point I do want to make is these types of technologies, the reason they're so in vogue is because they look like this. 4 days a year you might have a truck out there pumping a little bit of water in Dairy versus building a very energy-intensive water treatment plant that runs 365 days, 30 days, or 30 years in its lifetime. Okay, so this is a huge movement in the environmental field. Now it's just to kind of wrap up, as far as the environmental conditions, this is another slide that really conveys basically the green properties are places where we have really quite benign conditions. The yellow properties are places where there may be a restriction, like all of these have a restriction on drinking water. It's not really a big hindrance to us because we get our water through something else. Some of these have places where we have to dig kind of cautiously, but we can still do some things in the subsurface. We have some fish here. We always want to be mindful of the groundwater quality as it discharges to the river. And I guess lastly, I just want to leave you with these are assets on the ground. These green areas represent areas where we will have tree planting by spring of 2013.
So ultimately, by leveraging the assets on the site and seeking funding to address those, we've received about $2.2 million in funding to date, which is a starting point for us. Like I said, it's probably an $8 or $10 million project. One of the key things on the site that we wanted to do is begin work before we're fully funded, because we're never going to have that $8 million in the bank ready to go. So we've got to work as we go. We treat this as much more of an organic process, move pieces forward as it's possible. And this was a fairly boring talk, but tomorrow when we're on the site, you'll sort of get to see it. And I mean, everybody that goes on the site, almost to a person, is sort of energized by the project. So I guess that's it.
So I'm going to be talking this morning about two of our projects, a very small one in Milwaukee and then a much larger scale one in Detroit, to talk about some of the principles that we found helpful in dealing with vacant industrial land and also other kinds of land. So just to build off the first two speakers, a lot of the same principles are really important. So ideas about how you can have spaces that function in multiple ways at once, ideas about being multi-purpose, are important in places where budgets are limited and where there are a lot of opportunities that you can build off one another. At the same time, it's also important to have projects that are very flexible because there are a lot of unknowns with really long development time frames, 30, 40, 50 years out. There's a lot of things you just don't know what the future might hold. So solutions that can be flexible and adapting to a wide range of conditions are also important. So to start, Erie Street Plaza is a small urban plaza in Milwaukee. It's about a quarter acre in size. It sits at the point where the Federal Reserve Channel empties into Lake Michigan. So at the project's beginning, this was a vacant parking lot in the middle of an industrial district. And so because it was in the middle of an industrial district, there weren't a lot of stakeholders around, there weren't a lot of uses of the site at the beginning. So it's important to have a design that can function in multiple ways and accommodate a wide range of uses so that as a new neighborhood emerged around it, it could accommodate the neighborhood was interested in. At the same time, we also had ideas about stormwater management, so how the site could actually function as a filter, capturing clean stormwater from the site, and also accommodate larger flooding either over land or also from the lake. And so the result is an environmental amphitheater that steps down as it goes towards the water. Starting at the top of the site, there is a grove that functions to buffer harsh wind coming from that direction. As you move towards the middle of the site, it's a hybrid plaza green, so spaces for sort of picnicking, soft spaces in addition to hard spaces, so it can accommodate a wide range of uses. And on the lowest portion of the site is this stormwater marsh that accommodates stormwater runoff to feed the various plants that live there and also accommodate flooding from the lake. So over time, there has been development that has occurred nearby. So there's a restaurant on the site. In the background, you can see some of the tables from an outdoor patio that they've constructed. There's also a new condo building nearby. And so the site really functions as an environmental amphitheater that people can look out from the different levels, see the boats going by in the water. It also functions environmentally to capture and clean stormwater. And it's really given a new presence to this area, all different seasons of the year, and all different times of the day. So then to shift gears and spend a little bit more time on a much larger scale project. So Stoss has been involved in the Detroit Works project, so it's a strategic framework plan for the city of Detroit. And we're specifically working on issues of landscape, ecology, open space within the plan, and so it's a much larger team. And Dan Kincaid of Hamilton Anderson will be here this afternoon to talk about some of the broader goals, which include issues of economic growth, land use, city systems, neighborhoods, and public land. But I'm going to focus more specifically this morning on landscape and some of the opportunities that we think landscape has in dealing with vacant land of many kinds at many different scales. So just to give you a comparison, Erie Street Plaza, the one we just looked at in Milwaukee, is about 1/4 of an acre in size. So that's like one of these itty bitty tiny dots on this map. So in Detroit, the problem is there's a lot more opportunity because of the vacant land is so much more pronounced. And so we're interested in ways that you can use this vacant land in many different sizes in many different places within the city to do a wide range of functions and help address some of the city's challenges that it faces today. So some of these include, first of all, Detroit sits within the Great Lakes Basin, so it's part of a much larger regional watershed. And one of the key challenges that it faces, like many cities in the Northeast or in the Midwest, is that its sewer system is combined. So that means that stormwater pipes also carry sewage from homes, businesses. And during dry weather, the sewage is treated at the treatment plant and then released once it's clean. But during wet weather, if there's too much stormwater, it means that the stormwater combines with sewage in the pipes and suddenly it exceeds the capacity of the treatment plant. And you have untreated water getting discharged into the local rivers. And so this is something that, although the city's made some improvements in recent years, it still continues to be a problem and it still continues to violate both state and federal standards for clean water. Another major challenge that the city faces is contamination and pollution in many different forms. So this is a map showing many different kinds of soil contamination, ongoing pollution. The City of Detroit, by comparison, has 72 Superfund sites, so that's just one particular type of brownfield. In addition, there are many others. So this is just showing brownfields that are either classified as Superfunds or on a couple of different state and federal listings. There are probably many, many more in the city that haven't yet been detected. So the contamination is really of a couple different kinds. So one, most of these Superfund sites are legacy contaminants. So past land uses had impacts, so spills or other releases of chemicals that continue to contaminate the soil today. One of the other things that's still a challenge is ongoing pollution from active industries. So this is things like discharges into the water, air releases, in addition to some of the infrastructure facilities. So there's an incinerator live in just northeast of downtown, this general area. And in addition to that, there's also vehicle exhaust from the interstate. So people that live close to interstates are more likely to have asthma and other respiratory problems because of the pollutants associated within the exhaust coming from the heavy traffic. And so living near any of these things is very damaging to health in a number of different ways. So all sorts of different diseases are correlated with living close to these environmental hazards. And what we found is that it's not everyone in the city isn't equally likely to be impacted by these problems. There's certain portions of the population that actually bear a disproportionate burden of these issues. And so those are people that tend to be lower income, minorities, and children as well. And so this is a map that overlays some of the worst contaminants on percentage of people that live in poverty. You can see the darker colors are areas of higher poverty that tend to align pretty closely with some of the former industrial areas, current industrial areas. And so we're interested in the ways the landscape can help address some of these issues. So as a whole, it's unsurprising that Detroiters suffer from higher incidences of cancer, heart disease, respiratory illness, and diabetes than the national average. Some of these can be traced back to the environment, like where people live. So traced back to homes that are too close to these environmental hazards, but they can also be traced to lifestyle factors too. And so one of the other things that Detroit is currently having a problem with is providing sufficient high-quality recreation for its population. So compared to similar cities in the Rust Belt or similar cities in size, geographic area, Detroit is one of the lowest funded in terms of dollars per acre of park. It also has one of the lowest availabilities of park space. And for this reason, there's currently a problem with having enough money to maintain the parks in the city. So currently about 30%, 25 to 30% of the parks are actually receiving limited maintenance from the city because there just isn't funding to actually maintain them at a normal rate. At the same time, the spatial, where the parks are in the city is not necessarily where people are living. So the red on this map indicates areas that have relatively low vacancy, but very little park access. And on the other hand, some of the areas of higher vacancy in the city are actually some of the best served by park space. So we just need to act to try to find a way to rebalance so that people, so that all neighborhoods have access to parks for healthy recreation opportunities. And so just to summarize, so given all these sort of issues, we need to find unconventional strategies that reduce burdens on existing infrastructure. So ways to address the stormwater, combined stormwater overflows. Ways to find new recreation areas that cost less to maintain. Ways to really find to put productive land or put vacant land into productive uses. Then in turn, all of these things can help improve the health of the city, its residents, and its citizens. And so this is where we look to landscape. We think landscape is a great opportunity because it's relatively inexpensive, especially compared to conventional ways of to do remediation or other things. It can really help heal both people and environments. And it's also an opportunity to be enriching and educational, so it's a good learning opportunity for people. And we think that landscapes are really interesting to look at because they can do a lot of different things, both in terms of recreation, economic growth, neighborhood stabilization. They can help reduce maintenance costs while also providing new economic opportunities. And so during this process, we looked at a range of case studies to sort of look around the world and close to Detroit to see what we could learn from in terms of using landscape in innovative ways. What we found is that there's already a really big, thriving urban agriculture movement in the city of Detroit, both in neighborhoods and also in downtown. So this is Lafayette Greens in center of downtown. And there's also farm stands, farmers markets, things of that nature. And ideas for larger scale urban agriculture opportunities that would combine job training, aquaculture with greenhouses and food processing on the table. And some of these things, there are many ways you can do things like urban agriculture even with contaminated soil. So we're looking at some of those opportunities. We're also interested in looking more broadly at what are some of the other ways that you can use landscape as a tool of innovation. And so some of these other examples are Sweetwater Farms in Milwaukee. So this is a facility in formerly vacant industrial building, so they've repurposed it to have a new use of growing vegetables and also producing fish. So two different things you can eat. And it's interesting because the vegetables, they help clean the water, which provides a good quality of water for the fish to live in. At the same time, waste from the fish goes to fertilize the vegetables, so it's an interesting cycle. There are opportunities for biomass, so innovative ways to produce energy. Opportunities for, this is a forest in Mexico that's run by the local community, so ways to sort of combine community outreach with economic growth. And then we've also been trying to figure out what are the ways that you can help reframe vacant land as an opportunity. So these might be things that help rebrand, reshape perception. So this is in DeSalle, a branding strategy where plots of land are painted to indicate that they're cared for by different people. And then the last couple of examples are just innovative ways to do recreation in combination with remediation or other uses. So this is a park by Turnscape in China, and so there's these different pools. They look different because there's different contaminants, and so they have different strategies to deal with them. And as a result, there's just different kinds of experiences that are created for the people that come to the park. And this one in Germany, that's a former rail yard that had a forest grow up around it and has now become a park. And one of the other interesting things is that because there are such long time frames for development, there's a need to find ways to use the space in the short term. So what are some of the interim programming opportunities that can help that activate space? And so Westergasfabriek in Amsterdam, it used some of the industrial buildings for a wide range of temporary programs, so fashion shows, sort of other exhibitions, just outdoor dining for people. It was a way to help activate, gain community interest while development of the rest of the park was still ongoing. And so in Detroit, we've really been looking at what are the different kinds of landscapes that can work in a variety of ways to help address these problems that the city is facing. So I'm going to run quickly through these 5 different types and explain them in a little bit more detail. So the first one is community open spaces. So this is parks, plazas, many different sizes. It's also small-scale food cultivation, so community gardens for neighborhoods. Some of these might be large parks. So these are things, if you're familiar with Detroit, but Belle Isle, Chandler Park, Homer Park. They might also be plazas in the city center. And then, so the second main type is ecological landscape. So these are just natural landscapes. So if you have a plot of land, you just don't do anything to it, you just leave it. These are things that develop naturally over time. So forests, meadows that gradually become forests. These can have really important ecological benefits in terms of providing habitat for local wildlife, migrating birds. They also don't cost very much to build or maintain because you can just let them happen. These are things that are already starting to develop in Detroit to a certain extent and will continue to grow as population falls. And so another category is working in productive landscapes. So these are landscapes that provide economic growth opportunities. So there are things from urban greenhouses to maybe piles, areas to collect resources if you deconstruct a building, so stop lots. There might be research landscapes or urban forest. Gives you more of a sense of what that could look like. So if you have blocks that start to be aggregated together, so opportunities for larger scale greenhouses, maybe aquaculture. And there are also interesting opportunities that can emerge between these and then the employment districts that the plan is also looking at creating. So there are opportunities for products from this landscape, whether it's food products, forestry products. Those can actually provide physical inputs to the employment district as a base for different kinds of manufacturing. At the same time, these are also places of innovation, so we're really interested in the ways that there could be new research opportunities. So these are places where there could be partnerships between industry, different institutions, either locally, nationally, or even globally. And they can really help create new ideas that can then inform production in a little bit different way. One of the specific inputs that we've been especially interested in is food, because these are large areas, so and the greenhouses have an opportunity themselves to create a lot of jobs. But what we found is that the jobs are actually even more pronounced in the food processing industry. So there are a lot of jobs where you grow the food, but then it's when you process it to make new food products, and that's where the jobs are greater. And one of the ways that these two things work together is that in order to have these higher jobs in the industry, you need a local source of food to help provide the input to that. So currently in Detroit, there are a lot of large institutions, universities, hospitals, that prefer to buy, they don't necessarily buy local food because there's not a year-round source of food available locally. So they prefer to deal with one dealer somewhere far away that can ensure that they'll have produce year-round. We think that it's an interesting idea that if you have a local source of food in Detroit year-round, like these greenhouses can do, then that can actually allow a system-wide shift. So you go from buying food far away to buying food locally. So you're creating jobs in the greenhouses that are growing the food, but then you're also allowing the change system-wide to this more local food processing as well. So we think that the benefits of urban agriculture can really expand across multiple kinds of the industry. Transitional landscapes are the fourth category, and so these are temporary landscapes that either clean soil or provide new forms of social life. So these might be plots of fields or flowers that clean contaminated sites. There might also be new kinds of opportunities for recreation, festivals, events, and art within a wide range of contexts. So finally, blue and green infrastructures. These are a new kind of infrastructure, so they're landscape-based, so they both work to clean air and also clean water and capture stormwater. And so the first one, so green infrastructure, these are forested bands that clean air, either along industry or along interstates. And they also act as amenities, so they can provide things like trails that go through them. They can be a visual amenity for things that are close by. But most importantly, they're capturing pollutants from passing cars or from industry and cleaning the air and helping it be more healthy for the people that live nearby. And so these forested buffers might be narrow next to light industry. They might be a lot bigger next to heavy industry in the city, so things like Marathon Oil in the Southwest. And so blue infrastructure are things that capture and clean stormwater. So landscapes that can be everything from a rain garden to a larger retention pond. we've been looking at what are the different kinds of opportunities for blue infrastructure, so different kinds of systems. So things from small scales to large retention ponds that can work together to create citywide networks to clean stormwater. So one of these, for instance, is a surface lake. So this would be located at areas of low points in the city's topography. So we think it's important to work with the existing contacts in the city's existing topography to find ways that are efficient to deal with stormwater. What it might look like in areas of that are located popularly. And so we're interested in the ways that these systems can work together to create integrated systems and that create new open spaces for the city of Detroit. They work in many different ways, provide flexibility in decision making. And so the idea is to use these multi-purpose spaces to create new forms of interaction both at individual sites, so whether it's the rail yards that are in the middle of the forest, new kinds of neighborhoods that are built with landscape fabric, and also new kinds of cities that are green and sustainable for the new century.
So while you get this up, I'm going to cheat the system and get an extra minute. My name is Susannah Drake. I'm a landscape architect and the founding principal of dlandstudio in New York City. And my talk today is called Ecology, Public Space, and Infrastructure. And my practice is really involved with creating resilient urban environments. Sorry, this is a fast one. So infrastructure is a term developed in the World War II era in reference to military logistical operations. But cities really require a much more holistic view. We as landscape architects and designers work with habitat, color theory, drainage, geomorphology, horticultural, restoration, geography, soil science, sociology. And really, cities are these complex systems. We often think of this kind of model of the city as being this gray megalopolis, but there's also this inherent ecology that exists underneath, as referenced in Eric Sanderson's Manhattan project of this higher ecology. Cities are places of exchange, and specific structures were set up to facilitate this kind of exchange. But ecological systems are also about exchange, and they both have their own specific properties. So cities are also about movement. They're again, sort of in pure examples, the ideas of traffic systems coming through the city, rail systems, road systems. But then there are these hybrid systems, such as Riverside Park, where you have both together. And then an idea of a stacking of movement, such as Clark and Lloyd proposed, or actually implemented in Riverside Park, where they put the rail yards underneath the park, extending Olmsted's idea of this juxtaposition of movement systems with green systems. So containment can work in terms of how we manage water. These are actually the same landscapes down in Lower Manhattan, but they can also break. So this is the same landscape again as a result of the 1938 hurricane. This was a Category 3 hurricane called the Long Island Express, which brought a huge amount of water into this area of Lower Manhattan. So, and one of the things that we really need to think about with some of these the increased instance of climate change impacts is the economic risk. We face a potential sea level rise, I'm looking at mostly at projects in New York City, potential sea level rise of 6 feet over the next 50 to 80 years. And that would inundate huge portions of the city. But on the flip side, there are also incredible economic benefits that can be gained by looking at how green infrastructure can improve the environment. And what we did in this study was actually discover in sort of creating a one-page graphic from a 400-page U.S. Forest Service document, suggesting that the 10-year gain on planting 350 street trees would be $50 million. And that's in cleaning the air, in cooling the air, in filtering the pollutants in the air, and in recycling the water. So I'm going to talk now about some specific sites, mostly in Manhattan, and if we have time, a video of a project that we did in Montreal. So this first project, we had one slide up last night, was for the Brooklyn-Queens Expressway. It's this highway corridor that runs through Brooklyn and Queens, as the name suggests. And I have two projects. One was more theoretical study in the Carroll Gardens neighborhood of Brooklyn, and then another over in the Williamsburg neighborhood. So my vision really was to take this 6-lane highway, trench, scar, as you will, and create a vision for how we might green the city. In the near term, we had notions of how we might sort of change the geometry of the street in order to add those 350 street trees that I suggested before, and then also potentially form safer crossings to some of the existing parks. But in the longer term, we had ideas about how we might cap this entire 20-block area. And this was not sort of a naive notion about, oh gee, if we only had $1 billion, we could cap this whole area. We really looked very specifically at the places that needed the intervention the most, and had a whole strategy for a sort of longer-term implementation that could be phased. And the other idea was that there could be development sites adjacent to, not in this new open space, where you'd have upzoning along those orange corridors, or orange lozenges. So in Williamsburg, we have a much smaller site. This project is a little bit more real. This is probably a $100 million project. But we have a highway trench, and we're working with City Councilwoman Diana Reyna to look at strategies for how we might create new open space for this predominantly Hispanic community. Through a series of meetings with the community, we discovered that they really wanted to have more recreational open space. They have tot lots, they have smaller scale space, but it's not useful for them. So we also looked at the feasibility of the capping of this area of the trench. There are bridges that go over that are about 50 years old. They need to be replaced. They're at the end of their lifespan. So with an idea of replacing those bridges, we looked for places where we could actually make the structure fairly thin and then top that structure with an artificial turf. And then have these edge conditions have lush, more real planting, so all the drainage would actually go over to the side as well. So in that way, we were able to get the new sort of federal highway standard clearances that we need. We were able to add this additional open space by rebuilding these bridges and then expanding to cover the adjacent open areas, potentially leverage a city expenditure of $20 million that would have to happen because they need to be replaced with a potential federal grant of 80, given the structures of the way that funding operations are happening now, through a HUD federal redevelopment grant. So we're trying to look at both the needs of the community and the ways that we would fund this and the kind of ecological needs of the city to create this plan for this 2-block area, which would activate this whole space. So the next issue that I deal with a lot in my practice is combined sewer overflows, as Jill suggested. When we get even a 20th of an inch of rain in New York City, we have these combined sewer overflows where the stormwater combines with the sanitary sewage and it flows into the harbor. On average, we have 400 million gallons of this combined effluent going into New York Harbor every week. So I've tried to think very systematically about how we might manage some of the stormwater. And one of the places that we operate, or we have a sort of contained amount of water, is in these raised highways. So we started thinking about the relationship of these CSOs to infrastructure and how we might trap that water. Now, we don't really love this water that's coming off the highways. The road pollutants from cars and surface sediment include heavy metals, oil, and grease, and they include copper, lead, cadmium, hydrocarbons, zinc, and iron, and all of that is going directly into our harbor, or it's going into this combined system. So what we wanted to do was actually create a series of swales to capture this water. We're working with the Bronx Center for Environmental Quality on a pilot project where we're looking at capturing the water in a kind of pop-up swale. So the idea here is that we take planters, basically a simple box, and we retrofit them in order to have a very specific engineered soil and very specific plantings and a sedimentation basin and an ability for the whole system to drain and manage the right amount of water. So it's very simple, a very simple idea, but it requires a bit of sort of finessed engineering. And then we also thought about if we weren't allowed to release the water into a drain or even across the surface once it had been cleaned, we could potentially put it into one of these pop-up swales with a dry well. So another strategy that we've considered is having that water go into a series of swales that just exist at the base of the structures, and you're probably looking at this and saying, how can plants grow in the shade? But we actually did a whole analysis of the geometry of the highway structure in relation to the sun angles to determine what plants could grow in this area. And the idea here is that in the long term, we start with the pop-up and see how it works and see how much water it is and experiment with the kind of plants that grow best in this particular microclimate. And then we could potentially do this more integrated system as part of the development of this kind of expanded catchment area with the expansion of Mill Pond Park. So this would be sort of the 20-year scheme, whereas the other one is the 1 year, this is what we can do right now kind of scheme. So before we got that project, we got a grant from the Department of Environmental Protection to do some other experiments over in Flushing. This whole area is a giant floodplain, and it's the site of the former World's Fair, or a number of World's Fairs in its history. There are discharges from all of these raised highways into Flushing Creek. And so we're developing 3 different prototypes that we actually broke ground on yesterday, I'm happy to say. So it's a good thing. For different topologies, this is all an experiment. The conditions are very tricky here because we have a very high water table and we have soil that basically is like cement. So in this case, we have almost like what I showed you before with the raised planter, but it's submerged. Again, with the sedimentation basin and the planting bed. In this case, we're trying using gabions, so cages that are filled with gravel, and burying those in the ground in order to distribute the water evenly. And this is what that one would look like. It's sort of like it kind of feels like a garden. And then in this case, we had a very high water table, and we had issues where we had to stretch the swale fairly far away from the highway in order to get the sun. So in this case, it's more of a raised kind of condition. So we look at the capabilities of plants to absorb different toxins, to take in different amounts of water, seeing which ones are salt tolerant and which can accumulate heavy metals. And then think about sort of more of the specific, drill down on the specifics of their capacities. And then think about how they might look at in different seasons in order to come up with these integrated stormwater park plans. The next project I want to talk about is the Gowanus Canal Sponge Park. I think this park is important because it started as a community vision for the management of stormwater. And a community group came to me and said, we want to do rain barrels and green roofs and think about how we might capture some of the stormwater. And I said, well, I think what we really need is a very comprehensive vision of what to do for the whole area. And it's a very diverse community, and it's a community that can be resistant to even planting street trees or having any kind of planting, much less planting swales in their backyards. So I thought I have to figure out some way to characterize what we're doing that isn't so techy, isn't so about stormwater management and phytoremediation and talking about swales. So we came up with the term sponge park, and it was like this miracle term because people thought that we were dropping in from heaven and we were going to soak up all of the rain and it was going to just solve all of their problems. And there are big problems in Gowanus. This image on the bottom, this is basically raw sewage floating on the top of the water. We have a fairly large watershed, but in taking this holistic view, what we realized was that we only needed 11 acres of permeable ground in this whole area in order to absorb the 1.2-inch rain, which was our required sort of level by state regulations. So we sought to, or we tried to find that land. But here you can see the problem of the stormwater in the area, and that stormwater brings with it all of this garbage and sediment. And this is, again, the sewage on the top of the canal being held back. We analyzed, or we looked at where the outfalls were, where the direct drainage was happening, where the storm drains were, and where there was a pump station. This pump station takes fresh water from the East River and basically flushes it through the canal, so it really is like flushing a toilet. But that pump station has also been broken for a period of time, so that the area has become kind of a stagnant cesspool. But we came up with this overall master plan of what you might do, with strategies for upland landscapes that could be more recreational, with strategies for in the water landscapes that could start to absorb some of the toxins in the water, and for a whole sort of range of opportunities in between. But as a beginning, we wanted to explain sort of how these systems were working. So in an average rainfall, these upland filtration swales, which would occur all around the canal, would absorb the water. But when we have a heavier rainfall, our idea was to connect to the storm drains and take that water down to a street end basin. So our street end, this is an example of one of the street end sponge parks at Sackett Street, and a view south to the cultural redevelopment area. This is a beautiful old building that's now, actually it was just recently purchased for an arts organization. So in the middle of doing all of that work, our area was declared a Superfund. So there was a rezoning that was happening. There were all these positive things that, well, positive, some people thought they were positive things. The city was doing a lot of cleanup. The Army Corps of Engineers was already working on the site. But in the eyes of the state, it wasn't going fast enough. So they kicked it over to the Army Corps of Engineers, who declared the area a Superfund. And this red arrow shows the extent of a plume of toxins from manufactured gas plants that existed on the site. So that stopped everything. It stopped all the development that was happening. It stopped all the cleanup that was happening by the Army Corps, because they had to do a whole thorough analysis of what to do, what the proper procedures would be, how they could operate. But we kept going. And we kept going because we had gotten a grant from City Council to do a first pilot project, which I'll talk about in a minute. But one of the things that's really interesting in working in New York City, and I'm sure it's true here probably as well, and certainly in lots of cities, is the sort of regulatory structure of how you operate in an urban landscape. And in the Gowanus, for example, like the sediment underneath the canal is controlled by the Army, well now the EPA Superfund was the Army Corps of Engineers. Shade over the water is controlled by the Department of Environmental Conservation. The first 5 feet of soil in the upland areas is controlled by the Army, or by the Department of Environmental Conservation, whereas the roadbed is actually Department of Transportation. The water that goes over the road is the Department of Environmental Protection, and the plants that are fed by the water belong to the Parks Department. And then there are setbacks that are determined by city planning of 20 to 40 feet. In certain cases. And so it's just this quagmire of different agencies at the city, state, and federal level. And then that doesn't even bring into account the 20 different community groups, all with different agendas that are working in the area. So in spite of all that, we've kept going. We have a pilot that is going to start construction in the spring. We got a grant from the New England Interstate Water Pollution Control Commission to do the grant, or to do the construction drawings for this first piece. And we're working with a very strong team, small core team that includes Wilder Engineering, Montclair State, Center for Urban Pedagogy, and the Gowanus Canal Conservancy, among others. We calculated the water volume that was flowing down the street ends, and then figured out the capacity of both the upland swales and our street end to capture that water. There were a series of existing green streets which we removed. We're forming this as a series of bioretention swales. There's a sedimentation basin. This is the layout plan. And I'll actually just show you how that works. Churning a little bit. But basically, these are existing sidewalk swales. Okay, come on. Work. There we go. Okay, good. That's good. Okay, these are the existing conditions. Okay, so we take those out, those green streets. We're going to reuse the plants elsewhere in the city. We put in the street swales. And then we're building these bioretention cells as a modular system because it's easier to construct. And it'll be easier to, easier to build off-site and then also easier to replicate. It has an integrated sidewalk and sedimentation basin. And you can see there are little slots between to allow the water to go through. And this is a pedestrian path with an integrated sand filter below. So that's for any storm that's over the 1.2-inch storm, which accounts for 90% of all storms that happened in New York City last year. So it rains, swale fills up, rains more, sedimentation basin fills up, and that water is distributed evenly to the cells. And you can see now the water's going to go in between them as well. So the plants are going to absorb all that water, and the soil's going to filter all that water. Then it rains more. Big rain, big rain. And so it fills up again. And in this case, it goes into the sand sedimentation filter, or not sedimentation, the sand filter. Okay, and then it'll release into the canal. So, and then the idea is that beyond its sort of productive capacity, that this site would become, a new open space for the community. Okay, and that is the sponge part. And am I at 2 minutes? Can I show a 2-minute video? All right, okay. And I'm going to skip MoMA, which is all about coming up with an integrated system of managing stormwater for New York, and go to this 2-minute video of a project that we did, which talks about some of the same kinds of ideas, but it's in Montreal. So this is what that sound. So. You guys can fight something kind of mellow, and then something happy, like any dirgy music now. The transportation systems across the nation form our real estate, and how we might transform those systems in the city of Montreal to make them more productive on a number of levels. Create better ecologies, create more economic opportunity, purify the water, sort of look at a bold new vision for how the city might create this stronger connection, both basically from the airport to the center of the city, but how that might become a new model for North America. Thank you.
Susannah, anywhere else but the plant, are you going to have a live band accompanying your presentation? We have about 10 minutes left. originally we were going to ask Joel and Steve to moderate a discussion with you all first, but if it's okay with you, we'll just go straight to questions from the audience.
Perfect.
Okay. So any questions for any of our panelists?
Yeah, I have a question. It's amazing stuff. I was wondering though, in terms of especially Chevy-in-the-Hole, but also for any of the other projects that were discussed, was there any discussion of, when we talked about reclaiming the land, or was there any discussion of reclaiming the remembering the history of the site? Especially with the Chevy-in-the-Hole, it's an amazing, important history.
Yeah, there's definitely been a lot of thought that went into it. We actually went so far as to have our member of Congress, Dale Philly, write a letter to the Park Service, which triggered an investigation by the Park Service into the historic nature of the site because of the labor movement starting there as one of the older auto sites in the country. Their determination was that since none of the buildings exist, that it's basically slab, that it was not a good candidate for any federal park investment. We disagree with that, and we think that there will be ultimately, once the greening is done and we start to look at the amenities that will be on the space after remediation and greening takes place, I think there's no doubt there will be some tribute to the labor history of the site and the industrial history of the site. But it doesn't appear that it'll be, through the Federal Park Service. It'll be a local initiative that takes place there.
Yeah, I mean, definitely I think the reuse of the space and the strategies and the thinking of the team embodies the history of the space. And embodies the history of General Motors in general, right? It was a bunch of rogue car guys, and they were almost like cowboys, right? They were definitely not, your Henry Ford type. It was, General Motors was a bunch of car nuts, right? That was their reputation. And I think with regard to Chevy-in-the-Hole, we're kind of, take this the right way, but we're kind of making it up as we go. This isn't your conventional brownfield, so we're flying a little bit by the seat of our pants, and I think that roadness sometimes emulates a little bit of GM's history, and I think certainly, we'd love to plant something and be able to see the Chevy logo from the sky or something, or possibly as some of the stuff begins to evolve, you might see a monument to the labor movement or to the history, embracing the history, certainly.
The one kind of cool thing we got is you have sort of these weird, unique bricks that form the floor of a lot of these areas, and we're going to begin before remediation, before we cover these up. We're going to try to reclaim as many of those as we possibly can, and I think that'll probably form some sort of basis for something we do in the future, whether it's a path or a square or something on there. These reclaimed bricks would be sort of cool in that space.
In Gowanus, not only is the U.S. Army Corps of Engineers the EPA Superfund doing an analysis of all the historic resources in the site, we also had to do a presentation to the Public Design Commission, which is kind of a challenging, it's another regulatory layer that I didn't mention, but a very picky one. But one of their issues was that there's a lot of historic cobble in the Gowanus area, and so the DOT, the Department of Transportation, has been burned a number of times in not addressing the cobble. So it wasn't in this presentation, but we did a whole analysis of when cobble was used in the neighborhood and how, and did these maps and these graphics showing that distribution in a very clear way, and showed how basically what we were doing is kind of redistributing. We were maintaining the historic character, but it didn't fit the current use. So we were thinking about the materials and sort of their deployment, and also thinking about when the green streets went in as well, because that was a historic moment as well, and thinking about how we might sort of shuffle. And they were very pleased with the fact that we were recognizing this history, reinterpreting it, not monumentalizing it, not sort of fetishizing it, but working with it. So.
Next question.
I was really captured by your visuals, and I wondered if it's possible to have any of those photos of the people that have attended or send links or something so that you can share with more.
Sure. We'll work with
The other,
Stephen and Jerome to see if we can get it thrown up on the website or something like that. So,
and then the other thing I'd like to say is, I live up here a lot away from that area, and I just statement about the question. I'm thrilled to see the research that you're drawing from, to be able to rehabilitate that. I've been reading all this kind of research for close to 50 years now, and to see it finally coming into place is more than exciting. I don't know how to I'm going to
thank you. Great.
have a good time.
I was just interested in Susannah and Jill's response initially, just from some minimal information to the presentation on Chevy-in-the-Hole conditions of decided, whether you have any thoughts about how your practices inform or could inform that particular site condition.
So I thought this was a great presentation, and in a way, we're all completely like minds. I think that we all are pursuing the same strategies. We just have slightly different sort of angles on how we get the information out there and even how we would sort of form it. I saw this terrific opportunity in what you're doing from a design perspective, and particularly given the fact that you have this orbit of cultural institutions. And I thought that was one of those sort of significant things that you said is, look, I can see them from here, so they can see me from where they sit. And that's such an important relationship that whole site presents such a great opportunity. And I see, just the fact that you had this formerly natural system that ran through that area not that long ago. And so, I know that it's a regulatory lift to think about sort of the softening of that corridor, but, ultimately, it seems like you're kind of like edging into that, right? You're going to say, well, we can't just say, okay, I'm going to rip out this big canal. You're going to say, okay, we're going to start doing it, and, through succession, and through taking away some of this pavement, that we're going to get there. But I thought that it was a great sort of introduction to that eventual process.
Absolutely. And the other thing I'll say, when you get to the site, it's one of those things where you look at it on paper and talk about it, but even the people in my own firm, they never get it until we actually take them there. It's what you'll have an aha moment, and especially the topographic depression part of it, because it's actually an asset potentially. It's a way. It allows us to have floodplain in the soil and to have some stormwater, have some unique green infrastructure and blue infrastructure, and so. And one of the concepts that we're always looking to employ at Chevy-in-the-Hole is how can we gain, what do we have that's free? Free energy. So we have the topography working for us. We have a river. We have all these things kind of going for us. And I think you guys are going to be, I think a lot of ideas will pop in your head as you see the landscape.
Yeah, and I was just going to build on and say, I think the opportunities for doing things in the short term, like the thing on Sunday where it's actually towards the site, just getting people there, I think these short-term programming opportunities are really exciting.
Yeah, I think that's a big part of it. I think initially, at least for me, I was really turned on because I wanted to see us do a lot of R&D and green technology incubation. While I think those things are really cool and I wanted to see those happen, those are off in the distance. And the social aspects are way bigger as far as just how can we get people in the neighborhood on site, get the dirt under their fingernails, get some ownership of it, and then it'll evolve from there.
I'm curious in the phytoremediation approach, your thinking or your understanding of using a life cycle kind of concept, what you do with the metals and the other components that could be trained in these plants?
Well, I'm not a scientist, so I probably can answer this as well as anyone else. But the phytoremediation strategy that we're employing here, these trees do not uptake or trim the metals necessarily. So if you think about trees, there are certain things that happen during this phytoremediation process. So basically, oxygen getting down to the roots of these plants and helping to break down and oxygenate the soil, that's really the strategy that we're using here, not necessarily to sort of wick up and phase transfer a bunch of contaminants out of the ground. Another major component of this is just reducing the amount of groundwater entirely on the site. So we've got low amounts of groundwater that moves very slowly. These trees, when they're mature, will transpire 40 or 50 gallons a day of water. We have 1,000 trees on site right now. We'll plant probably 4,000 or 5,000 when it's all said and done. And so you can imagine that sort of 4,000 or 5,000 times 40 gallons pretty much wicks the groundwater that moves across the site. So while we're oxygenating down the hydrocarbons and the things in the soil, we're also reducing the amount of water that moves across the site entirely. So that's more of a strategy. And then, these trees will have to be tested. They have about a 20, 25-year lifespan for the workhorses on the site, which are the phyto trees. We've got a strategy, a successional strategy, so that we'll have, our deciduous trees will be coming to maturity at the end of the life cycle of these trees. We'll test them. If they have uptaken any contaminants, we'll probably use them in something like a bio-burn facility. We've got a biomass facility, a 30 meg consumer plant just north of downtown here, or just north of the city. So that would be a good place to dispose of these trees if they are contaminated, because they've got stack scrubbers and everything.
Just to pipe onto that too, there are a number of trees that already exist, pioneer trees, cottonwoods, very similar in attributes, water-loving trees, and those trees don't demonstrate a lot of uptake of the kind of ubiquitous contaminants at the site already. So, and as Steve said, the literature really supports that at these kind of moderate levels, if we were putting trees in, just Chernobyl-like levels of contamination, we might expect something different as far as hyperaccumulation, but the trees are not known to be big accumulators of contaminants. The contaminants are kind of, they're a waste product to the trees, so they're kind of excreted at a very low level in general, and so it's one of those things that hopefully that isn't a big issue for us.
And what we're doing in Gowanus and in Flushing, actually up in the Bronx, is we're testing what's in the water going in and what's in the water going out, and testing what's in the soil, and testing the plants. So they're pilots. One is with a grant from NOAA, two of the others are Department of Environmental Protection. Oh, and actually the other one is NUEPIC, New England Water Pollution Control Commission. So basically we're going to figure out how the whole system works, and then figure out what procedures we need to undertake to sort of process the contaminants wherever they end up. But we want to find out where they're going to go first, because the city doesn't have a reliable sort of database of how green infrastructure is actually operating. And ours aren't the only pilots. There are other people doing pilots in the city too. So the similar kinds of data are going to be available in the next 5 years, so that the city can assess what the best sort of procedures will be for their overall green infrastructure plan.
Yeah, we'll take one more question.
I was kind of curious if any of you have looked at myco-remediation, remediation with mushrooms and fungus. And I'm just curious if I've read a lot about it, and I've not read a lot about it in practice.
Yeah, I've done it 22 years ago, I worked for an R&D firm that did it like high-rate composting. They composted paper from like Burger Kings all over, and we used white rot fungus. And fungal remediation, I would say it's not like the first thing. We've definitely looked at it, and it's maybe in our purview. It's not the first thing that we'll stampede to, mainly because most of the contaminants here, and I don't want to get too technical, but other than a lot of the organic contaminants here, we already see evidence that they're degrading via kind of indigenous bacteria. And so we're just going to goose that, or at worst, not screw that up as we alter and improve the site. First thing is always don't make it worse, and then if we make it better, right, then, so I would say that is something that, is like on our radar screen, but off to the side a little bit.
So many of the environments I work in have a saline environment. I don't know if they work in that, but I haven't tried.
I've read of them doing it for even oils, clean up
Really?
on top of. I think they use it in the San Francisco Bay.
Well, I want to thank all of you for your presentation. Just a couple of announcements. announcements. So they refer to tomorrow's program. We're going to be at Chevy-in-the-Hole starting at 9 a.m. on Stevenson between Bluff and Glenwood. You'll see the gates are marked, and we'll be able to tour the site, go out on the site with Steve and Joel, and all of our visiting artists and designers. So please join us if you're around tomorrow morning. And after that, we'll walk to Kettering University's International Room for 2 workshops. One, to learn more about the site, to build on some of the information that Joel and Steve talked about today. And secondly, to do a hands-on workshop with James Rojas, who was in the audience a second ago, a 1-hour workshop to reimagine how can we activate the site right now. Not a couple years in the future, but tomorrow, over the next 6 months, over the next year. What kinds of activities can we bring back to that site?